My name is Neil Glasser. I'm Professor of Physical Geography at Aberystwyth University. I'm here to talk about a paper that we've just had published in Nature Scientific Reports. So this is an area of South America we'd worked in before, and on all our visits there we noticed that around one of the really big lakes in the area, Lago Buenos Aires, there are some terraces, really high terraces, about 100 metres above the lake at its present level. So we'd worked out that something must be damming the lake. The lake must have been much bigger in the past in order that the terraces could be raised higher. So we set about trying to find out what had caused that lake to be dammed, and we worked out quite quickly that there'd been a big ice dam, a glacier dam at the western end of the lake. So the research project was based on trying to find out the age of that ice dam, trying to calculate the volume of the lake, and then trying to calculate what would have happened when the dam failed and the lake drained suddenly and all the water was released into the ocean. The rapid drainage of the lake was because it was dammed by a glacier on the western side of the lake, the western end of the lake. And when the glaciers retreated, you had a big body of water that was held back effectively by this ice dam. Then the glacier pulls back and the dam would suddenly fail, and all the water would be released very quickly out into the Pacific Ocean. And we're talking about a huge volume of water. It's about 1,500 cubic kilometres of water. And that's obviously difficult to imagine what 1,500 cubic kilometres of water look like, but it's about the size of 600 million Olympic swimming pools. So it was a huge quantity of water that was released very quickly. Initially some of it was released eastwards into the Atlantic, and then suddenly a lot of it was released westwards into the Pacific Ocean. We work with some people who do ocean models, and what they're able to do is to run an ocean model with suddenly inputting fresh water into what's effectively a salty ocean, and that changes all the currents. So what happens is, for a number of years afterwards these events, there's a change in the ocean circulation in the Pacific, and we get very different weather, very different temperatures around the southern part of South America. So the parallels are really important because the lake drained very quickly and input all this fresh water very quickly into the Southern Ocean. Now that isn't happening at the moment because the glaciers there are receding slowly and are constantly putting out small amounts of water. But what we are seeing further south in Antarctica and then further north in Greenland are the big ice sheets rapidly putting lots and lots of fresh water into the oceans, and that changes the ocean circulation. Ocean circulation is based on the salt water and the fresh water, how they mix or how they don't mix. So the big parallel from this research is what might happen present day to the big ice sheets in Greenland and Antarctica, and how they put fresh water out into the oceans. The lake we study is in South America, and we know there were big glacial lakes across large parts of North America, in Canada and America, and also in Scandinavia. And I guess that now that we've managed to date effectively the drainage of one of them, and we've managed to do the runoff calculations on how it affects the oceans, I suspect the next stage of this research will be to try and do the same for the big lakes in North America and in Scandinavia, yes.